Hey guys, welcome back to our series doing the FreeCodeCamp JavaScript algorithm data structures course. So last time we left off doing functions. We were learning scopes, um, but when I came back to continue, and I'm sorry the video ended abruptly last time, but I noticed that there were a few lessons. I think about four maybe lessons that have been either added or adjusted, and so now we have to go back and do them. So we're gonna do them real quickly, and then we're gonna continue with our where we were with functions, and hopefully we can get some real progress done today. So I think this is lesson number 9. It's called explore the differences between variable and let keywords. I think this should have been in the ES6 section, which is down here, but I guess they wanted us to go through it early on, so we're gonna go ahead and do that. So this lesson is called explore differences between the variable and let keywords. One of the biggest problems with declaring variables with the var keyword is that you can easily overwrite variable declarations. Variable camper equals James, variable camper equals David. So we declared a variable called camper, assigned it a string value of James, then we overrid it using a different string called David. So, and if we were to log this, we'll get David. So in the small application, you might not run into this type of problem, but as your code base becomes larger, you might accidentally overwrite a variable that you do not intend to. Because this behavior does not throw an error, searching for and fixing bugs becomes more difficult. The keyword let was introduced in ES6, a major update to JavaScript to solve this potential issue with the variable keyword. You learn about other ES6 features in later challenges. If you replace the variable with let in the code above, it results in an error. So if I say let camper equals James and then say let camper equals David, this will throw an error in the console. So unlike variable, when you use let, a variable with the same name can only be declared once. Update the code so it only uses the let keyword is what we're challenged to do. So simple. Let cat name equals Oliver and let cat sound equal meow. And so that's it. So again, using let, and I was to reuse the name of a variable later in my code, it's going to throw me an error. It's going to tell me that I've already used the name camper, the variable name camper, earlier on in my code. But if I was to use variable, the variable keyword, the var keyword, this is not going to throw an error. JavaScript will accept this, and if I was to ever, run my code and some error comes out, this is going to be a lot harder to fix. So that's one of the new lessons. Continue to the next one. This is called declare a read-only variable with the const keyword. The keyword let is not only the new way to declare variables. In ES6, you can also declare variables using the const keyword. Const has all the awesome features that let has, with the added bonus that variables declared using const are read-only. They are a constant value, which means that once a variable is assigned with const, it cannot be reassigned. So if I say const favorite underscore pet equals cats, and then I was to go again and try to overwrite this and say fav underscore pat equals dogs, the console will display an error because I'm trying to reassign pet, but I've used const, and const is a read, makes this variable favorite pet equals cats into read only. I can no longer manipulate this. You should always name variables you don't want to reassign using the const keyword. This helps when you accidentally attempt to reassign a variable that is meant to stay constant. A common practice when naming constant is to use all uppercase letters with words separated by an underscore. Note, it is common for developers to use uppercase variable identifiers for immutable values and lowercase or camel case for mutable values, objects, and arrays. You will learn more about objects, arrays, and mutable values in later challenges. I think we've already covered this. Also, in later challenges, you will see examples of uppercase, lowercase, or camel case variable identifiers. We definitely did this. So here we're told to change the code so that all variables are declared using let or const. Use let when you want the variable to change, and const when you want the variable to remain constant. Also, rename variables to declare with const to conform to common practices, meaning constants should be all caps. So we want variable FCC to be FreeCodeCamp and variable fact to be cool. So fact can change, right? So we can see FreeCodeCamp is cool or FreeCodeCamp is not cool, whatever. So we can name this to let. Again, see, we're changing it here, so this is okay. But we want FCC to be a const because we always want FCC to mean FreeCodeCamp. So FreeCodeCamp is always awesome, and that's that. Oh, right, almost forgot. If it's a const, it should be all uppercase. This is not something that I'm used to doing, but in this instance, this is definitely something that I will also have to personally adjust to. So. Did I not? Oh, I didn't change it here. Okay, now it should be good. Yep, there we go. So we'll continue. So we've done these lessons. So I have to go back to the curriculum, back here, and all the way towards where we were doing the function lessons. This was called return a value from a function with return. We can pass values into a function with arguments. You can use a return statement to send a value back out of a function. Example, function plus 3, passing a value called num, and so we want to return num plus 3. And then so here we're calling plus 3 by saying constant answer is equal to plus 3. So we're passing 5, so 5 is going to be added to 3, so the answer is going to be 8. Plus 3 takes an argument for num and returns a value equal to num plus 3. Create a function called times 5 that accepts one argument, multiplies it by 5, and returns the new value. So this is real simple. We're going to say a function called times 5. We're going to pass it an argument called num, and we're going to return num times 5. Then here we can say const ans is equal to times 5, and we pass in 3. We can log it, see that answer is going to be 15. Simple. Right, so if you ever want to return a function, right, if you want to return a value out, let's say you pass in an argument and you want to do some computation and you want to get a value back from the function, you use a return keyword. Otherwise, I could just go in here and just manipulate it. I could say, I could create I could do a local variable in here, right? A scoped variable. I could say let ans equal 3, then do num times ans. This is fine, but I'm not returning anything. So whatever happens inside this code block here stays in here. This can never be accessed anymore. So that's just something you can keep in mind while we use the return keyword. Alright, let's keep it going. Global scope and functions. In JavaScript, scope refers to the visibility of variables. Variables which are defined outside of a function block have a global scope. So we've done this. Pretty sure we've done this, but we'll do it over again, because this is where we left off anyway. This means they can be seen everywhere in your JavaScript code. Variables which are declared without the let or const keywords are automatically created in the global scope. This can create unintended consequences elsewhere in your code or when running a function again. You should always declare your variables with let or const. Using let or const, declare a global variable named myGlobal outside of any function. Initialize it with a value of 10. So anywhere around here I could do let or const. I could say const, what did it say, myGlobal is equal to 10. Then it says inside function fun1, assign 5 to oops global without using the let or const keywords. So here I can say oops global is equal to 5. So as you can see, this is a global variable because it's declared outside of any function block or any code block for that matter. It doesn't have to be a function. It's declared outside of a code block. So I can access my global and its value 10 anywhere in this code. I can even call it in function 1 if I wanted to. But I'm using it here, right? So my global, this works. My global is not undefined. So I can render out this output, right? My global is 10. Now, oops global is declared inside of a function, so that means it only exists, or it can only be used inside of this function block. So oops global equals 5, which actually, I'm so sorry. Let me rephrase what I was about to say. Since if oops global was declared using let, const, or variable, it can only be used. So if let's see here, if I said let global equal 5, you see how it doesn't appear here? It no longer the output no longer gets logged out, because now this only exists inside function 1. But because I do not declare it using let, const, or var, this is now a global variable. So this is equivalent of me saying let oops, if I was to declare oops global out here, right? These are basically doing the same thing. So that's why it's always important to use, the proper variable declaration keywords. So yeah, that's the lesson. Here we have a local scope and functions. Variables which are declared within a function as well as the function parameters have local scope, which is basically what I briefly covered in the last part of the previous lesson. That means they're only visible within that function. Here's a function called myTest with a local variable called lock. So this is the code block function myTest, const lock equals foo. If we console log lock, we get foo. It's going to print out foo in the console. So if I was to call myTest, this is what we're going to do. It's going to do this. But if I was to go out here and say console.log lock, it's going to throw me an error, right? We'll throw an error as lock is not defined outside of the function. So the editor has 2 console logs to help you see what is happening. Check the console as you code to see how it changes. Declare a local variable myvar inside my local scope and run the tests. So if I had to do here, as I said, let myvar equals, I'll just give it the name. See, as you can see, this is inside the local scope. So, and I'm using it here. So here it says inside my local scope is my var, and I'm calling my local scope. Then it says the console will display a reference error. My var is not defined, but this will not cause the test to fail because I'm calling it out here now, my var. But my var is only be declared inside of a function block, so I can't access it outside of this function. So that's why this part is saying my var is not defined. So let's continue. Global was as local scope in functions. It is possible to have both local and global variables with the same name. When you do this, the local variable takes precedence over the global variable. In this example, we have a constant variable called sumVar is equal to hat. And here I declare a function block. I have a function block, and I use the same function, that variable name sumVar, declare the same way using const, and I call a head, and I say return sumVar. So the function myFun will return the string head because the local version of the variable is present. Add a local variable to my outfit function to override the value of outerwear with the string sweater. So again, what's happening here is because this exists locally, if I was to return sumVar, right, it's going to return head. It's not going to return hat. So if I was to declare, let's say const var2 is equal to myFun, it's going to be whatever is written in sumVar. It's not going to be hat anymore. So here it says add a local variable to my outfit. So we'll say const outerwear is equal to sweater. So if I was to return outerwear, it's going to be sweater. It's not going to be it's not going to be t-shirt. So variables with the same name declared inside of a function block take precedence over global variables with the same name. So that's the lesson here. Did I not write sweater? I misspelled outerwear. Sorry. Okay, let's continue. Understanding undefined value returned from a function. A function can include a return statement, but it does not have to. In the case of the function doesn't have a return statement, when you call it, the function processes the inner code but the return value is undefined. Example, let sum equals 0. Function adds sum. We pass in an argument called num, and then we say sum is equal to sum plus num. And if I do add sum 3, it's going to pass 3 to add sum, then sum is going to be whatever sum, it's going to be sum plus 3. So add sum is a function without a return statement. The function will change the global sum variable, but the return value of the function is undefined. So because here's an example of a function that only manipulates a variable value, or just a variable in general, or some sort of data type, right? It manipulates it, but it doesn't return a value, right? It doesn't return anything. So this is what's happening here. We just want to change the value of sum of this variable, do some math here, and that's it. We don't want to do anything else. Here we're instructed to create a function called add5 without any arguments. This function adds the sum variable, but its return value is undefined. So, give me 1 second. So we want to say function add5, and we're passing a number, and we want to say this function adds 5 to the sum variable. So we want to say sum is equal to num plus 5. And that's it. We don't want to return anything. I'm sorry, this should be sum plus equals 5, not sum equals num plus 5. So actually, in fact, here we didn't need to actually pass in a variable anyways, but whatever. Assignment with a returned value. If you'll recall from our discussion of storing values with the assignment operator, everything to the right of the equal sign is resolved before the value is assigned. This means we can take the return value of a function and assign it to a variable. Assume we have a predefined function called sum, which adds two numbers together. Then the variable rsum is equal to calling the function sum, passing it 5 and 12, which is going to make rsum equal 17. Call the process arg function with an argument of 7 and assign its return value to the variable processed. So here we say let process equal 0, but instead we can do this. We can call, actually no, I could actually do this. And we wanna, with an argument of 7, so I'm passing 7. So what's gonna happen here, processed is gonna call process arg first, passing in a value of 7. Then inside here it's gonna return 7 plus 3, which is 10, divided by 5, which is 2. So processed is now gonna be equal to. So this is gonna happen first before it assigns the value 2 to processed, is what's happening, is what basically this lesson is about. Stand in line. In computer science, a queue is an abstract, so we're getting into data structures already? A queue is an abstract data structure where items are kept in order. New items can be added at the back of the queue, and old items are taken off from the front of the queue by a function called next in line, which takes an array and a number item as arguments. Add the number to the end of the array, then remove the first element of the array. The next in line function should return the element that was removed. Okay, so this has already been set up for us. We have a function called next in line, takes in an array and an item, and we want to return the item that was removed. So here we could say item is equal to array dot. Actually, I'm sorry. First, we're supposed to add something to the end. So we pass item first. And then we want to return array.unshift, which is removing from the front. So this should be it. Okay. Let's see what happened. Was it shift to remove from the front? Yeah, it was shift. Sorry. Yeah, there's a lot of array functions that you can use to manipulate arrays. So the proper way to do it. So first we needed to push this past item, this whatever this value is, into our array. So we use array that push because we want to put it to the end of an array. Right? This is how queues work in data structures. You add to the end, we move to the front. So we pushed item, which is what we needed to do. Then we needed to return the item that was removed from the front of the array. So we do array.shift, not unshift. Unshift is how you add to the front. Shift is how you remove from the front. So, I got those two mixed up. But that's how this challenge is to go. So if we were to test this, right, we create an array called test R. We have 1, 2, 3, 4, 5. Then we log the array before we manipulated it. So we have 1, 2, 3, 4, 5 as we created the array. Then we do the manipulation. We call a next line. We pass in our array 1, 2, 3, 4, 5. Then we pass in the value of 6. So then we wanted to log what happened after the array was manipulated. So we removed from so first we added 6, right? So we do array.push. We pushed 6. So as you can see, 2, 3, 4, 5, 6. But we also needed to remove the front with this array.shift and return that value. So that's why this is what's happening here. It did the return. It gave us the return. Then it console logged the new array or after it was manipulated. So yeah, cool. So remember, shift remove from the front, unshift push to the front. Just I got those two confused. Understanding Boolean values. Another data type is the Boolean. Booleans may only be one of two values, true or false. They're basically little on-off switches where true is on and false is off. These two states are mutually exclusive. So actually, what I should have done here, I'm so sorry, is just keep an eye on how far down we're getting. So we've finished all the basics of functions. So now we're getting into Booleans and Logics. So this is going to be all the if statements, equal to, not equal to, greater than, less than, less than or equal to, greater than, equal to. So all that cool stuff. And then we still have quite a bit of ways to go. How many challenges have we done so far? We've done 57 out of 113. So we're about halfway through. So we'll keep going. I think we're gonna do. How far in are we? Is this recording so far? We've done 22 minutes. We got about 10 more minutes. We can get done with. So let's keep going. See how far we can get in 10 minutes. So understanding Boolean values. Another data type is the Boolean. Booleans may only be one or two values, true or false. They're basically little on-off switches where true is on and false is off. These two states are mutually exclusive. So again, Booleans, same thing as thinking things are binaries, like ones and zeros, or like as an example here, true or false, on and off. It's either one or it's the other. Boolean values are never written with quotes. The strings true and false are not Boolean and have no special meaning in JavaScript. So remember that. I can't say, const is true equal true. JavaScript is not gonna like this, but I can say const is true equals true, right? As you can see, the keyword was that this is a JavaScript keyword almost, right? And JavaScript recognizes it, so that's why it's highlighted different, and I was to write true in string quotes. So just remember that. Modify the welcome to Booleans function so that it returns true instead of false when the run button is clicked. So simple, just change that to true. Use conditional logic with if statements. So if statements are used to make decisions in code. The keyword if tells JavaScript to execute the code in the curly braces under certain conditions, defined in the parentheses. These conditions are known as Boolean conditions, and they may only be true or false. When the condition evaluates to true, the program executes the statements inside the curly braces. When the Boolean condition evaluates to false, the statement inside the curly braces will not execute. So here's some pseudocode. We have if condition is true, do this. So here we have a function. This is basically a function example of using if statements. So function test, the function called test, we're passing my condition as an argument. Then we say if my condition is true, then do this, return it was true. Otherwise, return it was false. So then we call it test, we're passing a condition true, then this is going to be true. It's going to return it was true. If it passed false, then it's going to return it was false. When test is called with a value of true, the if statement evaluates my condition to see if it is true or not. Since it is true, the function returns it was true. So if I was to pass true here, it's going to do this small block here first. If it was false, it's going to just do the return statement. It's going to skip all this if statement, what's inside the if statement, and just go straight to down here to the return statement of the function itself. Create an if statement inside the function to return yes, that was true if the parameter was that true is true, and return no, that was false otherwise. So simple. So if was that true, then we want to say return yes, that was, oops, I need to use a comma here, yes, that was true. Otherwise, and a proper way to actually do this would be to write else, and then we put in return no, that was, whoops, no, that was false, right? But we haven't learned else statements yet, so we just go here and do return no, that was false. And here we'll console.log true, and see, whoops, sorry, I'm supposed to console.log true or false and pass true. As you can see, it does, yes, that was true. And if I was to pass false, it says that no, that was false. So the first time I passed true, so this if statement was evaluated to be true because our condition is true. So it says yes, that was true. It returns yes, that was true. And if I was to pass in false, it checks if false is true, false is not true. So it skips what's inside here and goes straight down here and says no, that was not false. I mean that was false. So yeah, that's what was happening there. Here we get to equality operator and comparisons. So there are many comparison operators in JavaScript. All these operators return a Boolean true or false value. The most basic operator is the equality operator. The equality, which is the double equals. The equality operator compares two values and returns true if they are equivalent or false if they are not equivalent. Note that equality is different from assignment, which assigns the value on the right of the operator to a variable name on the left. So here we have an example function, equality test, we pass in my val. If my val equals 10, return equal. Otherwise, return not equal. So if I was to pass in 10, if I was to call my equality test and pass in 10, it's going to return equal. If I was passing 11, 12, 13, anything that's not 10, it's going to return not equal. It's just that simple. In order for JavaScript to compare two different data types, for example, numbers and strings, it must conserve one type to another. This is known as type coercion. Once it does, however, it can compare them terms as follows. So that's what, and this is, I hope that we'll highlight this point in the future, but I'll bring it up after I go over this example code here. So if I do 1 equals 1, this is game. If I do 1 equals 2, this is also game, right? I'm comparing two data types that are the same. They're both numbers, integers. If I was to do 1 equals string 1, what JavaScript is going to do is, this will work, but JavaScript is first going to change the string into a number, and then it's going to evaluate, and then it's going to, so this is essentially the same thing as doing this, right? But first it has to convert the type to the same thing as this, and then do the equality, and then compare the equivalent. Same thing here. 3 is a string versus 3 is a number. It has to convert the data types before it does the evaluation. In order to expression these expressions will evaluate to true, right? 1 equals 1. Does 1 equal 1? Yeah, 1 does equal 1. Or 1 is equivalent to 1. Is 1 equivalent to 2? No, 1 is a smaller number than 2, so this is false. This is true, right? Is 1 equivalent to 1 after conversion? Yes, this is also true, right? So it's basically saying is 1 equivalent to 1. And this is the same thing here. It's going to convert the 3 from a string to a number, and make them equal. Add the equality, not make them equal, and then see if they're equivalent. I should make that clear distinction. And there's something else I hope they'll cover in the next lesson or in the future lessons about strict equality. And that's where you will see that this is not going to fly and neither is this going to fly under strict equality comparisons. So here we're instructed to add the equality operator to the indicated line so the function will return the string equal when val is equivalent to 12. So here, if val, change this line, if val equals 12, return equal. Otherwise, return not equal. So if I was to, actually I should console.log test equal 10. I think they should have done this way instead of just in case it gives me, it wants this piece of code to be here. I'll just comment it out and uncomment it if it does require me, because I wanted you guys to see what's happening here. So if I was to call test equal and pass 10, is this basically what's gonna happen? Is that it's gonna say, is 10 equivalent to 12? No, 10 is smaller than 12, so not equal. But if I was to pass in 12, it's gonna say, is 12 equivalent to 12? Yes, so it's gonna return equal. So this is what's happening here. Yeah, okay, so it liked me doing that. Okay, so this is what I was talking about, strict equality, right? Strict equality is basically where this is no bueno. You can't do a number and compare it to a string. So strict equality is the counterpart to the equality operator, right? So triple equals, right? 3 equal signs is the counterpart to the double equals. However, unlike the equality operator, which attempts to convert both values being compared to a common type, the strict equality operator does not perform a type conversion. If the values being compared have different types, they are considered unequal, and the strict equality operator will return false. So if I was to say, is 3 equivalent to 3, right? So not only is it comparing values, but it's also comparing data types. So is the integer 3 equal to the integer or equivalent to the integer 3? Yes, that's true. They're both 3s, they're both integers. Then here it's going to compare, is the integer 3 equivalent to the string 3? That's false, right? We're comparing values, sure, but it's not gonna convert the types. So this is basically only gonna stop because it's gonna stop immediately when it realizes that these are two different data types. So in the second example, 3 is a number type and 3 is a string. It's a string type, so that's why it's false. Use the strict equality operator in the if statement so the function will return the string equal when val is strictly equal to 7. So val 1, 2, 3, not 2, 3 equal signs stacked, put 7. So again, I'm going to surround this with some parentheses called console.log. And here we'll pass 7. So you can see what's happening. If I pass 10 as an argument or as a value towards our function test strict, it's going to return not equal because 10 is not equal to 7. If I was to pass 7, it's going to return equal. And you can see that it's also going to return not equal if I was to pass 7 in quotes. Not equal because this is a string, that's an integer, not equal. So we'll do one more and then we'll end this video here. I'm only doing 30-minute segments because they're just quicker to upload to YouTube, and I can pump these out much quicker than doing 40, 50, 60-minute videos, an hour and a half. What I'm thinking about doing in the future is live streaming this and then uploading the live stream to YouTube. I think that might be a better idea, so that way I can do longer sessions and then put them up on YouTube so everybody else can also follow along if you missed the Twitch stream, or if I even stream it on. I think, that's the question I got to think about. Should I stream on Twitch or should I stream on YouTube? If I stream on YouTube, it's just going to be one platform, easier to put up also as a video. If I stream on Twitch, then I also have to record while I'm streaming, so I can also upload the It's a whole thing I got to deal with, but I'll think about it. But that's one thing I've been considering about doing. So let me know in the comments below if you've stuck around for this long, whether I should also do streams and upload the stream videos so that you have longer stretches of of courses and lessons going on, or should I just continue with the 30-minute segments for and just do like a handful of exercises? So here it says in the last two challenges, practice comparing different values. In the last two challenges, we learned about the equality operator, right? The double equals, the two equals next to each other, and the strict equality operator, the triple equals, three equals next to each other. Let's do a quick review and practice using these operators some more. If the values being compared are not of the same type, the equality operator will perform a type conversion and then evaluates the values. However, the strict equality operator will compare both the data type and the value as is without converting one type to the other. Here's an example. Here we're doing just an equality operation, right? Or equality comparison. Is 3 equivalent to the string 3? This is going to return true because JavaScript performs a type conversion. So it's going to change this to an integer and then compare them. And that's going to be true. It's going to be 3 equals to the integer 3 is equivalent to the integer 3. But in the second example, is 3 strictly equal to the string 3? This is going to return false because these are two different data types and type conversion is not performed under strict equality. Here's a note. In JavaScript, you can determine the type of a variable or a value with the type of operator as follows. So for us to do type of 3, it's going to return an integer or a number. If I was to do type of string 3, right, if I put 3 inside quotes, it's going to return me a string. So the compare equality function is in the editor compares two values using the equality operator. Modify the function so that it returns the string equal only when the values are strictly equal. So function compare equality takes two arguments, A and B. If A is equivalent to B, is essentially what's going on here, return equal, otherwise return not equal. So this is true. If I was to console.log, yeah, this is actually equal. This is true. And I hate them using equal instead of true or not because we just learned about Booleans. But if I was to change this to strict equality, then it says not equal. But if I was to change this to also be 10, then that's equal. So under strict equality, remember, under strict equality, no type conversion. It just compares data types. So if it sees a number and it sees on one side and a string on the other, automatically that's X. That's not it's gonna work. It's not equal. Under just equality comparison, so only two equal signs, right? Like that, it's gonna look at the data types. If one is different from the other, it's gonna convert them. And so they are the same data type, and then it's gonna compare them. So if one is a string, one is a number, it's gonna convert them both to numbers and then compare. So yeah, and that's it. So we are 55% of the way through with this section. This is where I'm gonna stop the video. I'm gonna pick it up back again where we are. Actually, I should do this so we can just keep an eye on what lesson number we are. So we've done 62 out of 113. So we're gonna be doing 63, which is so this is all gonna be comparisons. For a while, it's gonna be logics, true state, true ifs, comparisons, and all that good stuff. So this is where we left off. Practice comparing different values. I hope they're gonna do the same thing what they did last week, where they're gonna throw in some challenges somewhere along the way that we have to go back and redo or do, so we can be up to date. But so yeah, we've done 55% of the way through. We're gonna keep it going in the next segment. So thank you so much for watching. Again, let me know in the comments below whether you want me to stream and upload the streams to YouTube so that you can have longer videos where we do a full session, or should I just continue with these 30-minute segments and keep doing what we're doing so far. All right, thank you guys.